Right now, you are moving faster than a bullet, faster than a jet, faster than most things humans have ever built, and you don't feel a thing. The ground under your feet feels solid, still, calm. But it is not still. The Earth is spinning at about 1,000 miles per hour at the equator. At the same time, it is racing around the sun at nearly 67,000 miles per hour, and that's not the end. Our entire solar system is moving through the galaxy at around 500,000 miles per hour. You are part of all that motion, every second, every breath. So why does it feel like nothing is happening? This question sounds simple, but the answer goes deep into physics, human biology, and the hidden rules that control motion itself. The truth is stranger than most people expect, because the reason you don't feel the Earth moving is not about speed, it's about something far more powerful. In this video, you will learn why constant motion feels like stillness. You will understand how your body detects movement and why it fails to detect the biggest movement of all. You will discover the role of gravity in keeping you glued to a spinning planet, and you will learn a surprising fact. Even though you cannot feel Earth's motion, there are subtle ways scientists have proven it beyond any doubt. There is also a lesser-known detail that makes this even more fascinating. The Earth does not spin perfectly upright. It tilts, it wobbles slightly over long periods of time. That tiny wobble changes climates over thousands of years. It shapes ice ages. It affects the future of life on this planet, all while you stand still, feeling nothing. The real mystery is not that Earth moves. The mystery is why your brain ignores something so massive. Your senses are not designed to detect steady motion. They are built to detect change, acceleration, jerks, sudden shifts. That's why you feel a car when it starts moving. You feel a plane when it takes off. But once it cruises smoothly, the feeling fades. Earth has been cruising smoothly for billions of years. There is another hidden reason. Everything around you moves with the planet. The air, the oceans, the buildings, the mountains, even your body. There is no sudden difference between you and the ground. No sharp push, no violent pull. You and Earth are locked together by gravity in a perfect balance. And here is something that makes this even more unsettling. If Earth suddenly stopped spinning, even for a few seconds, the result would be catastrophic. Oceans would surge across continents. Winds would tear across the surface at terrifying speeds. The calm world you know exists because the motion is stable and continuous. The stillness you feel is actually the result of perfect, uninterrupted speed. By the end of this video, you will see motion differently. You will understand why speed alone means nothing without acceleration. You will see how gravity quietly overpowers the outward pull of Earth's rotation, and you will realize that being unaware of motion does not mean it isn't happening. There is a strange beauty in this truth. You are standing on a rock, flying through space at unimaginable speed, yet your mind experiences peace, stability, stillness. That contrast between reality and perception reveals something powerful about the universe and about how limited our senses truly are. Stay with me until the end, because the final explanation connects everything together in a way that changes how you think about movement forever. Once you understand it, you will never look at the ground beneath your feet the same way again. Welcome to our channel, where we break down big mysteries into clear and powerful ideas. If you enjoy exploring the hidden forces that shape our world, make sure to subscribe and join us for the next journey into the unknown. The first big reason you cannot feel the Earth moving is simple but powerful. It comes down to one rule. Constant speed does not create a feeling. Change in speed does. Your body is not built to detect motion itself. It is built to detect changes in motion. This is a huge difference. If something suddenly speeds up, slows down, or changes direction, your inner ear reacts. Your balance shifts. Your muscles adjust. You become aware. But if something moves at the same speed without interruption, your senses go quiet. This rule is part of basic physics. Motion by itself is not special. What matters is acceleration. Acceleration means any change in speed or direction. That is what you feel, not speed alone. When a car is parked, you feel still. When it suddenly accelerates, your body presses back into the seat. When it brakes, you lean forward. When it turns sharply, you slide slightly to the side. Every one of those sensations comes from change, from acceleration. But once the car reaches a steady speed on a smooth highway, the feeling fades. You can even forget how fast you are moving. The same thing happens in an airplane. During takeoff, your body feels the push, the engines roar, the speed increases. You know you are moving, but after a while, when the plane reaches cruising altitude and maintains constant velocity, it feels almost like sitting in a quiet room. You can walk down the aisle. You can drink water without it spilling. Your brain no longer senses the extreme speed, even though you are traveling hundreds of miles per hour. Earth works the same way. It is spinning at a nearly constant rate. It is orbiting the sun at a steady speed. There are no sudden jerks, no sharp increases, no quick stops. The motion is smooth and continuous, and because it is smooth, your body treats it as normal. There is something even deeper here. You have never experienced a moment when the earth was not spinning. From the day you were born, your body has adapted to this motion. To your nervous system, this speed is the baseline. It is the default setting. You do not compare it to stillness because you have never stood on a truly motionless planet. Your inner ear contains tiny fluid-filled canals. These canals detect acceleration. When you spin around quickly and stop, the fluid keeps moving for a moment. That is why you feel dizzy. That dizziness is your body detecting change. But if you rotate it at a perfectly steady speed with no variation, the fluid would settle, the signal would disappear, you would feel stable again. Earth's rotation is steady enough that your balance system stays calm. There is no strong signal telling your brain that something unusual is happening, so your brain assumes everything is fine. Think again about being inside a smooth train moving at high speed. If there are no bumps and you close the curtains, you cannot tell whether the train is moving or parked. You could toss a ball straight up and it would fall back into your hand. It would not fly to the back of the train. That is because everything inside the train shares the same steady motion. This shared constant motion hides the speed from you. Earth does the same thing on a much larger scale. The planet moves smoothly through space, and you move with it at exactly the same rate. There is no sudden shift to alert your senses. Even the outward force caused by Earth's spin is small compared to gravity. It does not create a dramatic pull that your body would recognize as movement. Instead, gravity keeps everything firmly grounded while the planet turns quietly beneath you. The key idea is this: motion feels dramatic only when it changes. Speed without change feels like nothing. Earth's movement is stable, balanced, and uninterrupted, and because of that, your senses remain silent while the planet continues its silent journey through space. The second big reason you cannot feel the Earth moving is that everything around you moves with it. You are not standing on something that is spinning beneath you while you stay still. You are part of the spin. The ground, the oceans, the air, the buildings, the trees, and your own body all share the same motion. Movement is only noticeable when there is a difference in speed between you and something else. This difference is called relative motion. If you run forward while the ground stays still, you feel it. If the ground suddenly shifts while you remain in place, you feel that too. But when you and the ground move together at the same steady speed, there is no contrast for your senses to detect. Think about sitting inside a smooth train again. If you look at the seat next to you, it looks still. The floor looks still. The air inside feels calm, yet the entire train is racing down the track. Because everything inside shares the same motion, it feels like rest. Only when you look outside and see the landscape rushing past do you notice the movement. On Earth, there is no outside window for your senses. The atmosphere moves with the planet. That means the air is not left behind as Earth spins. It rotates along with the surface. If the air did not move with Earth, we would experience constant violent winds at thousands of miles per hour. Instead, the atmosphere is mostly locked into the same rotational motion, so there is no massive wind tearing across the surface to remind you that the planet is spinning. The oceans also move with Earth. The continents move with Earth. Even the clouds are part of this shared system. Everything is traveling together through space. Because of that, there is no sudden sliding, no massive drift, no sharp pull between you and your surroundings. Your senses remain quiet because there is no difference to measure. The third big reason goes even deeper: gravity. Earth's gravity pulls you toward its center. This force is incredibly strong compared to the outward push caused by rotation. When Earth spins, there is a small outward effect, sometimes called centrifugal force, but it is much weaker than gravity's pull. At the equator, where the spin is fastest, gravity is only slightly reduced by this outward effect. The difference is tiny. You do not suddenly feel lighter. You do not feel like you are being thrown sideways. Gravity dominates the experience. This balance is stable. Gravity constantly pulls you down with steady force. The outward push from rotation is consistent and small. Because both forces remain steady, there is no sudden shift for your body to react to. You stay firmly grounded. If Earth rotated much faster, the outward force would increase. If it became strong enough, it would start to overcome gravity. Objects would weigh less. At extreme speeds, material near the equator could even break free, but Earth spins at a rate that keeps everything in balance. The motion is fast, but controlled. Even though you cannot feel the motion directly, there are clear signs that it exists. Day and night are the most obvious. The sun appears to rise and set because Earth rotates on its axis. The sky changes slowly, hour by hour. Shadows move. Light fades. Darkness returns. This cycle is a silent proof of rotation happening beneath your feet. Seasons offer another clue. Earth's axis is tilted. As it orbits the sun, different parts of the planet receive different amounts of sunlight. This tilt, combined with its yearly journey around the sun, creates winter, spring, summer, and autumn. The slow shift in temperature and daylight is evidence of a planet in motion. There are even more subtle signs. Long exposure photographs of the night sky show star trails forming circles around a central point. Those trails are not stars spinning wildly through space. They are the result of Earth rotating while the camera remains fixed. The planet turns, and the stars appear to draw arcs across the sky. Scientists have also measured Earth's rotation using precise instruments like the Foucault pendulum. A heavy pendulum swings back and forth in a straight line, but over time the Earth rotates beneath it. The path appears to shift. This simple device demonstrates motion without relying on feeling. Despite all this evidence, your body remains unaware. That is because humans do not have sensors for constant velocity. There is no built-in speedometer inside you. Your inner ear detects acceleration. Your skin feels pressure changes. Your muscles sense shifts in balance. All of these systems respond to change. When a bus hits a bump, you feel the jolt. When an elevator starts moving upward, you sense the shift in weight. When it stops suddenly, your stomach reacts. These are moments of acceleration. They create signals your brain can interpret. But when movement is smooth and unchanging, those signals fade. The fluid in your inner ear settles. Your muscles relax. Your brain assumes stability. Constant motion becomes the new normal. Earth's rotation and orbit are incredibly steady. They do not speed up and slow down in dramatic ways that your body could detect. The motion is continuous, balanced, and shared by everything around you. Because of that, the greatest journey you are part of feels like perfect stillness, even as the planet carries you silently through space. So here is the simple truth. The Earth is moving. It is spinning at incredible speed. It is racing around the sun. It is traveling through the galaxy, but it does all of this in a steady, smooth, and constant way. There are no sudden jerks, no sharp changes, no violent shifts for your body to detect. Everything around you moves with it. The air, the oceans, the cities, your own body. Gravity holds you firmly in place. Your senses only react to change, not steady motion. So even though you are part of one of the fastest journeys in the universe, it feels calm, it feels stable, it feels still. The silence of that motion is what makes it so powerful. Right now, without noticing, you are standing on a planet flying through space at unimaginable speed, and your brain translates all of that into peace and balance. That contrast reveals something important. Reality is not always what your senses report. Sometimes the biggest movements are the ones you never feel, and that leaves one strange thought behind. If you can be moving this fast without knowing it, what else in your life feels still, but is actually changing all the time? If this video helped you see the world differently, make sure to like it and subscribe to our channel for more deep questions and mind-opening answers. There is always more happening beneath the surface than we realize.